But so, like I said, we're looking at measures of central tendency, which, like I said, is the start of our statistics unit. I'm sure you guys have all heard of statistics before, but basically, what a statistic is, it's a way to kind of analyze your data. So, if you have like a data set, maybe you're conducting like a survey, or maybe you're doing some kind of research and you're trying to figure out if there's a connection between things or something like that. You would use statistics to try and analyze or explain your data. Like if you were doing an experiment, you could use statistics to kind of maybe kind of make some conclusions. So, like I said, we're looking at measures of central tendency, basically ways to look at kind of like the center of our data, or kind of like where does most of our data kind of fall towards. So there's different ways to measure central tendency. The first one is mean. Oftentimes, if a problem asks you to find the average, they're really talking about the mean. The mean's like the more proper way to say that. Um, Remember, to find your mean or the average, you're going to add all the values in your data set, press equals, and then divide by how many things were in your data set. One thing to kind of keep in mind, one symbol they're going to use for the mean is an X with like a bar above it or just a line. That means the mean. So let me just draw it a little bit smaller so it's not covering that up. But if you ever see like an X with a line above it, that's the symbol for mean. So if they're asking you to find this, that would be, they're really asking you to find the mean or the average. Well, one thing about the mean that you got to consider is that, like, one flaw with the mean is that it's influenced by outliers. If you don't know what an outlier is, that's just a number that doesn't fit with your data. So, for example, if we were looking at salaries, maybe we were looking at the salaries of, I don't know, a carpenter. Maybe the average salary for a carpenter is, I don't know, 50,000 a year. But there might be a carpenter that's um making, I don't know, like $300,000. Maybe they're like the fanciest carpenter in the world, or for some reason they can charge more. So one problem with a mean is that it's influenced by kind of extreme cases. So a lot of times, if you're looking at examples of like salary, you might want to look up the median. We'll talk about that in a second. But our next kind of measure of central tendency is our median. Sorry. So looking at our median, if you remember to find your median probably back from middle school, remember you put your data in order from small to big, or least to greatest. And then your median is basically your middle value. So you're going to kind of find what numbers in the middle. If there's two values in the middle, though, you're going to add them up and divide by two, or basically you're going to find the average between those two numbers if you have two numbers like in the center. Um, One thing to kind of talk about though is, so your mean is in, so the mean honestly is usually a better representation of your data, but your mean is influenced by outliers. So if you have some outliers, the median is going to give you a better picture. And a lot of times, like, I mean, I know a lot of you guys might not take a stats class, or maybe you're like, well, I don't need to know stats. Well, stats is actually a lot of times, I think it's honestly one of the most important kind of math things you should learn. Like I wish, instead of having two algebra classes, like algebra 1 and algebra 2, I really wish students got a chance to take a stats class, because a lot of newspapers or like news articles or politicians or lawyers, a lot of times they'll misuse statistics, or kind of cherry pick which statistics they use to kind of skew or kind of mislead people. Like there's been people that have like gone to jail or like served time because lawyers have misused like stats and the jury didn't understand like how they were being misled. So it's kind of scary to live in a democracy if where you have a jury, and if your jury doesn't understand basic statistics, I mean, you could be possibly falsely, like, I mean, you could be falsely in prison. It's happened. There was a woman once, like in Britain, that like she was falsely accused of killing her kids. And a lot of what put her behind jail was statistics. Like they try to frame it like it was impossible that the kids died of natural causes. So I mean, that's an extreme case, but I'm just saying. I mean, like it is really important for people to understand statistics, because a lot of times they're misused, or um, a lot of times they're not really understood a lot of the time too, I feel like. Um, so kind of an example of this though, like if whatever career or whatever you're planning on doing out of high school, if you're trying to figure out like how much money or how much income you're going to have, I would recommend you look up the median salary. Because for example, I Googled before class, like the average like household income in the United States in 2018 was like $87,000. Um, but the median average household sorry, the median household income was like $67,000. So um, one problem with money a lot of times is there's extreme cases. So if you have like billionaires and stuff like that, that's really going to skew your average or your mean. So while the average income in America is 87,000, less than half of American households bring less than 67,000. So when they say the average American has this or the average American, that's not always true because it's the average or your mean is skewed by either really high cases or really low cases. So a median oftentimes might give you a better picture if you have extreme cases. And with money, that's usually true when it comes to income. I mean, yeah, I hope so. I really do. But so but that's one thing to kind of keep in mind. Like a lot of times when you read like articles, they'll say the average American blah 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 blah. Like there really a lot of times there isn't necessarily an average American. Like um it might not honestly be like kind of like what you would expect most people to be like, especially when it comes to money. Like I said, with like billionaires and millionaires and stuff like that, it really skews the data. Most people, like if the average is 87,000, most Americans aren't having a household income of $87,000 because it's skewed. Um, so that's like an example. Like some newspapers, they might choose to use the average over the median depending on what they're trying to like spin the story as. So, like I said, I mean, you can kind of misuse statistics or kind of try and use statistics that support kind of what you're trying to say a lot of times. So you got to be really careful, and it's hard to know when you can't see the data sets that a lot of times these articles are using. Um, so just kind of keep that in mind with mean and median. But like I said, if you're ever trying to look at something with money, I would recommend you look up the median salary of whatever career you're looking at. Or if you're looking at house prices, look at the median house price. Because I mean, you're going to have mansions in some neighborhoods that are really going to skew like the average or stuff like that. So the mode though, honestly isn't really that much used, but the mode is basically the value in your data set that repeats the most. So if you have a number that happened a lot of times, if you're looking at a data set, that's your mode. Your range, to find your range is your biggest value minus your smallest value. I mean, to be honest with you, I mean, we're mostly going to be focused on the mean and median when it comes to measures of central tendency, but I figured I'd just talk about the mode and range really quick since I don't know, maybe you'll see that. All right, so we're going to look at an example of just finding mean, median, and mode. So let me just make this a little bit smaller. So it says the following, sorry, it says date, sorry, it should say data represents the number of points James scored in the first half of his high school basketball season. So you can see he had 8 games. Those were like his number of points. So he had 4 games where he didn't score any points. And then those are his last 4 games where he scored points. So to find the mean, remember, you're just going to add these up. And like, I mean, you're going to be doing your assignment in Delta Math anyways, but you're really going to just be putting this in your calculator. Is it not letting me write? Right. Sorry about that. So like for your mean, remember, you just add up all these numbers. Sorry, I know this is like chicken scratch, but and you're going to divide by how many things you had. So, I mean, if you just count, there's 1, 2, 3, 4, 5, 6, 7, 8 numbers in our data set. Just be careful when you put this in your calculator. You're going to want to put that top part in, press equals, then divide by 8. So if you do that, you should get 136 if you add the top. And then if you divide that by 8, you should get that your mean, sorry, this is kind of sloppy. You get 17 though. For your median, remember, before you do your median, you need to reorder your data set. You need to make sure it goes from small to big. So it's kind of a pain sometimes, but you really do need to do that step. So we need to reorder it. So the zeros go first, but then it would be 28, then 30, then 36, then 42. And when you do your median, remember you're trying to find the number in the middle. So you usually kind of cross one at both sides and kind of until you get to the center. If you have two numbers in the middle, you either want to find the number that's like exactly in the middle between those, or another way is you can just add these two numbers up and divide by 2. Basically, you're going to find the average between them. But if you work that out, 28 divided by 2 would be 14. Or if you think about it, what's halfway between 0 and 28? Well, that would be 14. It's exactly in the middle between those two numbers. Our mode is, remember, the number that repeats the most. So, I mean, that would just be 0. Your range is your highest value. So in this example, it would be 42 minus your smallest value, which would be 0. So your range would just be 42. And like I said, I'll be completely honest with you, at least, I mean, from my experience, mode and range really don't come up a ton. Really, if you're doing something, they would like if you do, when you do see this in your stats class, they'll probably be focusing on the mean and the median. And I know this seems really basic, like for middle school it is, but if you are taking like a stats class at Tri-C or wherever you end up, I guarantee you'll definitely talk about the mean for sure. Like you'll definitely be finding your mean stuff. Median, I would assume, but I could see some classes maybe kind of skipping over that, but I think it would come up in most. I know it like from Tri-C's like syllabus, they do mean median. All right. One thing I kind of want to demonstrate though is a lot of times when you're in a stats class, you're going to have questions where you kind of need to use your statistics, or you need to be able to explain your answer using what you calculate. Our first question, it says, in order to qualify for the All-Star team, a player must average at least 20 points per game. Does James qualify? So remember, average, when they say the word average, you should just assume they're talking about the mean. So his mean was 17. So, I mean, you would say no. His average or his mean. And sorry, I know this is chicken scratch, but you would say maybe no, because his average was 17, or however you want to word it. But I mean, basically no. It says James was injured and still recovering from surgery for the first 4 games of the season. Do you think he should be allowed to be part of the All-Star team? Explain your reasoning, using math to support your answer. So, and a lot of times in stats too, I mean, sometimes there might give you a question where it's kind of leaning one way or the other, but a lot of times there's really no right or wrong answer as long as you can kind of explain it. Like I said, a lot of times you can kind of frame things with different statistics to come to different conclusions. Not always, but so, I mean, I personally would argue that he should be allowed. And my reason would be, if you look at his games where he actually played, I mean, he averaged over 20 points in those games. Like, I mean, he had 30 points, 28 points, 42 points, 36. I mean, if you wanted to find his actual average in the games he played, I mean, you could just take that 136 we've got and divide it by 4, because that was like actually in games he played. So, I mean, if he did that 136 divided by 4, he really averaged 34 points per game. So, I mean, I would argue, I mean, but you could also argue no. You could say no, it doesn't matter. I mean, he only had an average of 17. Too bad. Sucks to suck kind of thing, I guess. I mean, too bad. Doesn't matter if you were injured. I mean, you could take that approach too. Like I said, I mean, as long as you explain yourself and try and use in the statistics you have, I mean, I think most teachers would take either. And I certainly would. I mean, because I think a lot of times there isn't necessarily a right or wrong, especially in a question like this. This is more of an opinion, but you do need to back up your answer. Okay, and then one more question I wanted to look at. It says, example 2, it says, you recently took your midterm exam in math class. You have learned that the class average is a 72%. Is it possible that you got an A on the exam? Explain how this would be possible or not possible based on the individual scores of the other students in class. So, I mean, I don't know how awake you guys are if you want to give me any kind of your opinion, what you're thinking, but one thing to keep in mind with the average is that it doesn't tell you about anyone's individual scores. Like if I looked at my quarter average, like if I looked at my second quarter average in this class here, let me actually, here, I'll look at it to actually see what it was. The average grade in this class for second quarter was a 70.01%. But if I look at everyone in the class, no one got, even though the average is a 70.01%, no one in the class got a 70.01%. Like no one even got that. No one was, I mean, there was a couple of people kind of close to that, but no one got exactly a 70.01%. So one thing to kind of keep in mind is that an average really doesn't tell you about anyone individually in the class. I mean, it might give you some insight if like the class average is like a 20%. That probably means if I was picking out a random student, they probably didn't do too well. But even if I had an average of 20%, I mean, someone could have got an A and like the rest of the class could have failed, you know, like, I mean, that would kind of average out to 20% if like everyone completely bombed it and then maybe one kid did well. Unlikely, but could happen for sure. So yes, it would be possible. And one thing, like your average, it tells you nothing about individuals. Or individual scores. So like, for example, I just like a quick kind of doodle of an example. Like, let's say we had a class of 4 people. Let's say the average on this test was a 50%, like, or like, yeah, let's just say it was a test. There was an average of a 50%. Well, I could have someone with 100%. I could have someone with a 0%. Maybe they just didn't take it or said they turned it in blank. And then I could have 2 people that got a 50%. I mean, you could check, and if you want to add these up, you would see that the average would be 50%. So here's an example where the mean or the average is 50% and someone got 100% or an A on their test. So like I said, I mean, the mean really doesn't tell you about anyone's score. And even though there's people that got 50%, I mean, I could have changed these too. I could have made this a 25%. Like, for example, I could have changed these. And this still would have a mean of 50%. And no one in the class got a 50%. So like I said, the mean doesn't tell you about anyone's individual scores. It just kind of gives you a good idea kind of where your class is. If my average in this class for second quarter was in 90%, well, that means overall people did really well in the class. If my average was 50 something percent, there's probably quite a few Fs, or there's probably some kids that aren't doing too well. So it gives you some insight, but keep in mind, like if you know the average, it doesn't tell you about any individuals, which is like I said, a lot of times how like news articles or politicians, like a lot of times statistics can be kind of misleading. Like when they say the average American, blah, 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 blah. A lot of times there is no average American, like there's no one that exactly fits what they're saying, if that makes any sense. Like if the average American, blah, 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 has this or that, that doesn't mean that every American has that, or even if there is an American that has exactly that. It gives you some insight into the whole population, but it doesn't tell you anything about individuals. So that's one thing to kind of keep in mind. Because like when you read something like that, like the average American makes this much money, you're like, well, then everyone's making that pretty much, like you would think, but that doesn't always have to be the case. And a lot of times they'll kind of cherry pick or pick different statistics that they use in articles. Sometimes it's not like intentionally done to like mislead people, but sometimes they know what they're doing. Like they'll specifically try and kind of pick statistics that shade something in a certain way. And so that's why, like I said, I mean, I think I'm glad I get to teach statistics for this quarter. I think it's something I really wish that was more in the math curriculum. I mean, to be honest with you, I like I said, I think 2 years of algebra, I think most students would be better served with a year of statistics, but I don't have any control like what the curriculum is for math. But If I had all the power, like I would have more students learn about statistics because I think I think it's more applicable to everyday life, even if you're not collecting statistics or dealing with statistics in your job. I mean, you'll always come across statistics like in either reading stuff or hearing stuff or um, depending on what you're doing. I feel like you interact a lot more with statistics than say like solving a quadratic equation. But um, I don't want to go on too much, but so that's it for our notes. You have a section in Delta Math, and honestly, in Delta Math, it's just basic calculating. You're just going to practice finding your mean and median from a set of data. So it shouldn't be too bad. If you need a refresher, definitely watch the video in Delta Math. That should be pretty helpful.